Hello and welcome to Apply Statistics using SPSS, and in this video I will show you how to perform a one-way ANOVA test in SPSS. And the dataset I'm going to use is a fictitious dataset that contains samples of mortgage interest rates charged by 4 different banks. And on the left hand side we've got the raw dataset, and what I've done is I've transformed the data so that we've got all the mortgage interest rates in one column here. Then I've associated a factor that corresponds to the bank number in this column. And this makes performing the test in SPSS more straightforward. We want to test to see if there's a significant difference between the mean mortgage interest rates charged by these different banks. And the one-way ANOVA procedure is a possible way of doing this. In terms of the assumptions of the test, so first of all, we must have that the groups or banks in this case are independent, and I assume that is the case for the purpose of this video. We must also have that the mortgage interest rates for each bank are normally distributed, and again I will assume that this is the case for the purpose of this video. But if you'd like to see more details on how we would check this, please see my video on test normality. And the third assumption is homogeneity or quality of variances, and I'll make a remark about this shortly. The other thing I'd like to say at this stage is that we can see that the sample sizes are different, and this will become important later in the test. So in SPSS we select Analyze, and then we have two options. We can either select Compare Means and One-Way ANOVA, or we can select General Linear Model and Univariate. I will go for Compare Means and One-Way ANOVA. And we move interest rate across to the dependent list box here. And bank is our factor. Then we select Options. And we want to test for homogeneity of variances, so I'll select this. And also we'll select Means Plot. Then Continue, and then OK. So here is our output, and this is the test of homogeneity of variances, and this is the Levene statistic and the corresponding p-value. So the p-value is 0.202, which is clearly larger than 0.05, the usual 5% significance level. So therefore we do not reject the null hypothesis that the group variances are equal. And this satisfies the third assumption of the ANOVA test. So we can therefore move to the ANOVA table. And we see that the p-value here is very small, smaller than 0.05, again the 5% significance level. So therefore we do reject the null hypothesis that all the group means are equal. This tells us that at least one of the group means is different, but it doesn't give us any specific information about this. And we'll have to do some further analyses to determine which group means are different. And if we look at the means plots, this firms up again that we've got some of the group means being different. So what we need to do now is further test to see which group means are different. And at this stage we've got two options. We can either use planned contrasts or post-hoc tests. So planned contrasts, these are used when specific hypotheses to be tested are stated before the experiment, which doesn't apply in this case because we didn't do this at the beginning of the experiment. And then post-hoc tests are performed when we have no specific hypotheses beforehand. So therefore we will perform post-hoc tests in this example. So we go back to Analyze and Compare Means and One-Way ANOVA. Actually, before we do the post-hoc test, I just want to make a quick remark. So we've got homogeneity of variances, but if we didn't have this, then we would use the Brown-Forsyth and Welsh tests. But we've got homogeneity of variances, so we will go back to post-hoc testing. So in the post-hoc test, we've got some options for equal variances assumed and equal variances not assumed. So you've got equal variances, so we will select a test from this box. I mentioned earlier that the sample sizes are different, and this means that we will choose Chef A's test. So the sample sizes are different, but they're not too different. If the sample sizes were very different, then we would opt for Hochberg's GT2 test. And further, if the sample sizes were all equal, then we would go for Tukey's test. We will stick with the 5% significance level. So then select Continue and OK. So here is our output. This is the table for the post-hoc tests. And we can see that at the 5% significance level, all the group means are significantly different apart from banks 1 and 2, which corresponds to this row in the table and also to this row, but this is just a comparison the other way about. And if we now look at the means plots, then this is reflected in the means plots. We can see that the mean mortgage interest rate charged by banks 1 and 2 is not significantly different, whereas all the others are significantly different. Okay, well I hope you found this video useful. If you have any questions, please let me know.